today's lesson, we're talking about the distance and the midpoint formula. A couple lessons ago in lesson 3, we found the lengths of segments using the segment addition postulate. Now, what happens if they take a segment and they plop it on the coordinate plane, like in example 1 here, and they're going to ask me, well, find AB, which means how long is this segment, AB? They asked me to find the exact length, which I'll explain what that means in a minute, and round my answer to the nearest tenth if it's necessary. Now, realize the segment addition postulate does not apply in this example because since the segment isn't horizontal or positioned vertically on the coordinate plane, I can't just count how long it is. Because it's slanted diagonal like this, I can't count it and be exact. I can get pretty close probably, but not be exact. So we have something called the distance formula, which helps us calculate the exact length of a segment on the coordinate plane. So copy this down real carefully. It's x2 minus x1. That's not x squared. It's like the second x minus the first x. That is a squared symbol. And then it's plus y2 minus y1, that quantity squared. Okay, so copy that down really carefully. This looks terrible. I'm the first to admit it. But guys, the distance formula is really just Pythagorean theorem in hiding. And I think we all know Pythagorean theorem. That's just a squared plus b squared equals c squared. So let me show you how Pythagorean theorem applies when you're finding the length of a segment on the coordinate plane. And then I'll show you how the distance formula is derived from Pythagorean theorem here. So again, Pythagorean theorem, we know it, a squared plus b squared equals c squared. This formula works when you're finding side lengths in a right triangle. I don't see a triangle in this picture. I don't know about you. So we create one. And to do that, you come to this top point, B, on our example here, and I'm just going to drop down a vertical piece and then bring a horizontal piece over from A, and boom, what do you know? Right triangle. Okay, let's call this A, let's call this B, and that's C. Okay, Pythagorean theorem would help me find C here, which that's exactly what I want. I want to find the length of AB, which is C, the hypotenuse of my right triangle. So A and B, since those are horizontal and vertical pieces, like I was mentioning before, I can just count how long those are. We kind of did this with segments on the number line in lesson 3. So down here for side B, I can just count it. So this is 1, 2, 3, 4, 5, 6, 7 long. Do the same thing with side A. That's 1, 2, 3, 4, 5, 6, 7 long. So I can set a Pythagorean theorem here. It'd be 7 squared plus 7 squared equals c squared. A and B are the legs, C is the hypotenuse. Hopefully this is familiar from algebra in middle school. And then I just do order of operations. 49 plus 49 is 98. And then to solve for C, you take the square root of both sides. That undoes squared. And my answer is C is the square root of 98. Now, exact length, that means that you need to do factor trees because they want it in simplest radical. So I want an answer that's like 2 radical 5. So I need to see if this will tree down. And it does. I can go 49 and 2. And this is the lesson, guys, that kind of we went off of when we were practicing radicals at the beginning of the year. So we needed that skill for this lesson right here. That says 7, 7, and 2. So to rewrite this, I have a pair of 7s, so I'd pull a 7 out, and the 2 would stay under. So that's the exact value of AB if I enter that down here. If I wanted the rounded answer of that, I would just plug it into my calculator. So 7 radical 2. And that's about 9.9 if I'm just rounding to the nearest tenth. Okay, so that's how long segment AB is. And I just showed you how to use Pythagorean theorem to find that. Well, back to the distance formula here. If you're looking at Pythagorean theorem, to find the value of C, which is essentially what I'm doing here, right here, to get C alone, I would square root both sides. And then I would have C equals the square root of A squared plus B squared, which kind of looks exactly like distance formula right here. But instead of A and B, they have this like x2 minus x1 and y2 minus y1. And where that's coming from, it's just taking these ordered pairs. So like A is the ordered pair -3, -4. And B is the ordered pair 4, 3. And it's basically saying to find one side of the triangle, you take the difference of the x values. To find the other side of the triangle down here, you take the difference of the y values. Okay, so that's the x and the y part. This is the first order pair, x1, y1. This is the second order pair, x2, y2. I'll show you how to use that on the back here, but realize if you're asked to find the length of a segment on the coordinate plane, you can just think Pythagorean theorem, which in my eyes is a little bit easier. So let's practice it again. So r is -2, -1, and I would go ahead and draw the picture. So there's r, and t is at -8, 7. Okay, so here's this segment, RT. I want to find the length of that segment. So for Pythagorean theorem's sake, I can just call it C. Now, again, you need to drop down a triangle. And I'm actually going to leave this one to you guys. I want you to finish this. So you need to count how long these two legs are on your triangle. And then you need to set up Pythagorean theorem. A squared plus b squared equals c squared. If radicals apply, do a factor tree. If it's not a perfect square number, you're square rooting. But I want you to try this and see if you can come up with the answer here. I'm going to check this when I check your notes next time I see you. For now, though, I'm going to shift gears and talk about a different formula. And we're actually doing like 2 lessons in once, which is kind of scary, but we're doing the distance formula and the midpoint formula. That's why it says like lesson 5 and 6. We're kind of squeezing both of them together and doing them at the same time. So this one's a little bit easier. And in life, it can be really helpful to be able to find the middle of something. So for example, if you're talking about like scores on quizzes in class, say Billy got a 60% on his first quiz, but then he got a 90% on his second quiz. If the teacher's like, hey, I'm going to average your scores or find the middle, it just means average, well, how would you do that? I feel like a lot of us know how to average scores. All you do is you add them together, 60 plus 90, whoop, and then you divide by how many scores there were. And there was only two quiz scores, so I would divide by 2, and Billy's average was a 75%. Most of us know how to do that. We can do the same thing with segments on the coordinate plane. Very exciting, I know. It's essentially just finding the middle or the average of 2 coordinates, x and y. So here's another formula. I gotta check, but I'm pretty sure I'll give you these formulas for our upcoming exam and our next quiz. I'll probably just like write them on the board. But here's what midpoint formula looks like. So it's not as bad, I don't think, as distance formula, but there's still a lot going on. It's x1 plus x2, and then that's y1 plus y2. Okay, there's 2 ordered pairs, there's 2 x values, there's 2 y values. That's kind of why the 1 and the 2 are necessary. Now, I want you to notice that the answer for finding length, which this is technically lesson 5, the distance formula, the answer for finding length was just a number. Like, I got 9.9. Hopefully down here on this example, you got a nice whole number as your answer. So if you're asked, hey, how long is this segment? It's just a number. But when you're finding the midpoint, that answer is an ordered pair. Okay, that's why there's parentheses here and a comma, because it's going to be like the x value, comma, the y value. It's an ordered pair location on the coordinate plane. So example 1 says, find the midpoint of this segment. You could eyeball it and say, oh, it's like right about there. But I want to be exact and give an exact ordered pair for the midpoint. So here's what I would do. I'm going to pick out what ordered pairs these are here. So this is -3, -3, and this is 2, 2, 5. Okay, I'm going to label these. I'm going to call this one x1, y1, x comma y, and then x2, y2. Since they're two ordered pairs, I need to note the difference. So if I start my midpoint formula, my new x value of the midpoint, I'm just going to take these two x values, -3 and -2, and I'm going to add them together and then divide by 2, since there's 2 points. I'm going to do the same thing with the y's. I'm just averaging the x's and then averaging the y's. So the y values would be -3 plus 5 divided by 2. Then I just got to figure this out. So -3 plus 2 is -1 divided by 2. I'm just going to leave that as -1/2. Or -0.5, doesn't matter. -3 plus 5, that's 2 divided by 2. And I am going to simplify that. So I'm just going to leave it -1/2, but 2 divided by 2 is obviously just 1. So that would be my answer. That's where the midpoint is. And I actually probably would have guessed it pretty close. It's that guy right there. Okay, so if you're asked to find the midpoint of the segment, it should be an ordered pair. It's a location on the x and y axis. Example 2 and 3 kind of bump this up to our level. We're in geometry class in high school, so we should be able to do a lot more math than just averaging numbers. And they don't even give me the coordinate plane here, so watch what I'm going to do. It says QS has endpoints. Q is 3, 5, S is 7, -9. Find the midpoint of that segment. We're going to call it M, and then find QM to the nearest tenth. Gross. This is asking us to do a lot. For the midpoint part, I just need to use the formula for Q and S, those 2 points. So I'm going to call this guy x1, y1, x2, y2. And I'm going to find the midpoint here. So I just need to add the x's and divide by 2, add the y's and divide by 2. And I don't even need a picture to do this. Of course the picture is always helpful, but it's not necessary here. You add the top first, so 3 plus 7 is 10 divided by 2, so that'd be 5. 5 plus -9 is -4. When I divide that by 2, it's -2. So there's the midpoint of this segment. Now they're asking me find QM, and they just list it like that. That shows me that I'm finding the length of a segment. Okay, and let me go ahead and list out the points I'm talking about. Q is 3, 5. M is what I just found here, 5, -2. Okay, I need to find QM, the length of this. So here's where I think maybe using the distance formula would be a little bit easier than thinking like Pythagorean theorem, draw a picture. Of course you could steal a piece of graph paper from me, like on an exam, if Pythagorean theorem is what you know best. But let me show you how you would use the distance formula. And actually, guys, I think for the sake of time, I'm going to hold off on this one, unless you feel like you could do it yourself, which if you feel like you can, go for it. For the sake of time, though, I'm going to leave this, and we'll just do this. And I'm going to show you how to do this in class next time. Okay, so leave that blank. I'm going to show you how to do the distance formula here. If you feel like you're smarter than me and you want to go and do it yourself, that's fine, because a lot of you can probably just plug and chug in a formula, no problem. But I'll show the whole class that next time I see ya. Example 3 here, though, let me just take care of this one. This one does have a nice graph, so that kind of is helpful for me at least. I like visuals. But it says the midpoint of KN is 3, 4. And I'm going to call that point M, the midpoint. And let's go ahead and plot that. So 3, 4, right 3, up 4. Okay, so there's M. One of the endpoints, K, for this segment, so the endpoints are K and N. K has coordinates -3, 2. Let's get that on the coordinate plane here. I want to find the coordinates of N. Well, let's connect these guys. So I know this segment is KN and M is in the middle. So N has to be somewhere up here. But I'm not totally sure where, because I don't know how long this guy is. But let me show you a couple different ways to do this. Honestly, if you have the graph, The easiest way is to just like think slope. And when you're thinking slope, you can just count it. So watch what I'm about to do. So obviously the line's going to look like this. I just count it like rise over run. So go to from K to M. So it'd be up 1, 2, 3, 4, 5, 6, and then right 1, 2, 3, 4, 5, 6. If I go up 6 and over 6 again, that's going to land me at N. And that puts M right in the middle. So let's do that. So it's right here, which is at 9, 10. Ooh, that's a small little graph there. Not cool. Okay, there's the answer. Let me show you one more way to do it, and then we'll call it a day. Maybe you don't like doing that. Maybe you're a formula person and just thinking like math, numbers, that makes more sense to you. You could just use the midpoint formula to work this out. So let me show you how I would do that. And sometimes people hate seeing two different ways, but deal with it. Okay, so you know K is this endpoint. So let's call that X1, Y1. I don't know N. I don't know those values. So, but we'd call it like X2, Y2. I know that I need to average the X's, average the Y's, and that's going to give me the midpoint. So I know if I do -3 plus X2, whatever that is, and divide it by 2, and then do the same thing with the Y's, that should give me what the midpoint is. 3, 4. Now I can just use math. I know that -3, the first coordinate here, -3 plus X2 over 2, that should equal 3. And I know that this guy should equal 4. Okay, so you could just set up equations here. Hopefully this makes sense to somebody. I know thinking slope just is so much quicker, in my opinion. But like to solve this, I would multiply both sides by 2, and then I would add the 3. So that is where the 9 comes from. For the y value, I would multiply both sides by 2, and then add 2. And that's where the 10 comes from. So those two examples kind of just bump it up to our level, but we'll do lots more practice next time I see ya, because formulas can be tough.